you need for all of those. And I'm going to stop this video because it's going really long. All right, let's keep doing this. What is the gear ratio between gears A and B? Well, that's just using the formula. What is the gear ratio formula? Is that number of teeth, 20T and 12T between A and B. All I'm gonna do is what the number of teeth out divided by the number of teeth in, so that's 12 over 20. And that equals 0.6 over 1, or just 0.6. So we have a gear ratio of 0.6. Now what that means is if you were to spin this, the driven gear, this other gear, the output gear, if you were to spin this one full time around, this would only spin 0.6 times. So that's what that means. Because you're doing output over input. If you spin this one full rotation, this will spin 0.6 of a rotation, so a little bit more than half. So that's what that means. Hopefully that makes sense. You have to, if one rotation around here, this has to travel more distance if you're thinking about the teeth, because it's a larger diameter. So moving on. What about the gear ratio between B and C? Well, that's just what, 5 teeth, 5 divided by 12. That means 0.42. And then between, well, I guess I guess what is C and D? C and D? What is that? Well, that would be 20 divided by 5. So that would be 4. So that means for every one rotation here, this would spin around 4 times. That's pretty nifty. To do compound gear, like to have the total gear ratio, all you're doing is multiplying this gear ratio times this gear ratio times this gear ratio. You just multiply all the ones that we just calculated, and that'll give you the total gear ratio. However, there's a shortcut for this. So let's see what that multiplication is. We had 0.6 times 0.42 times 4. So if you do that, you get a gear ratio of 1. So the total gear ratio between A and D is 1. But idle gears don't matter. These two gears in the middle, they don't really change the total gear ratio at all. The only thing that this allows for is maybe a change in direction. An idle gear allows for a change in direction, or it separates the two input and output gears. It also provides, like, you can attach another gear on here and have that do something else between these two gears. So if you have this and you want to spin this so that it it spins a drive shaft or something, but you also want to have a gear here that spins a different shaft for some other purpose, then you can put idle gears in there and I don't know, have that. So the shortcut, what just happened? The shortcut is to just find the gear ratio of the first and the last. Oh, did I record? Oh, whatever. So, so for compound machines, gear ratios are used similarly to mechanical advantage, just because, like, for mechanical advantage it makes things easier. For gear ratios, you spin one gear and it spins a different gear at a different speed depending on the gear ratio. So instead of using the mechanical advantage to apply to some force that we're inputting, we're going to be inputting or outputting torque. So if you have an input gear and you're applying some sort of torque there, you multiply it by the gear ratio, and that gives you the torque output. So it changes the torque output. So it's like allowing you to amplify or decrease your torque output similarly to amplifying or decreasing force input. So yeah, there you go. To get the total gear ratios, you just multiply them all together, just like mechanical advantage. Mechanical advantage is used to calculate forces. Gear ratios are used to calculate torques. So yeah, the rotational stuff. So let's say an example of a compound machine. All right, we have a wheel. Well, so like a wheel and axle. That's if we were to like extend this around, this would be a wheel and an axle. And then we have the gear train. That's this gear meshed with that gear, and we have another wheel and axle. So we'll be inputting some force here. It'll be transmitted through this gear, and then you'll have an output force. They in the PowerPoint they go through calculating stuff, but I'm just gonna explain this real quick. So if you wanted to calculate mechanical advantage and gear ratios for this, you do it kind of separately. First, you would calculate the mechanical advantage of this wheel and axle, and you would also calculate the mechanical advantage of this wheel and axle, this force input, force output, or actually we do ideal mechanical advantage because we don't know what our forces are. So we'd have to use the distance of the effort and the distance of the resistance for the actual axle. The distance of the resistance would actually be the gear. So here would be the wheel length. Actually, this is not a diameter. This is a radius. But if it were to extend all the way across, that's what we would have. Maybe D is for distance, not diameter. And then the axle radius, it tells us, is 1.5 inches. So you could get the mechanical advantage, the ideal mechanical advantage of each of those. To get the total ideal mechanical advantage, you would just multiply the two. The mechanical advantage from the first one times the mechanical advantage from the second one. And you'd keep that separate of your gear ratios. You don't mix the two calculations. If you're calculating gear ratios, you're just calculating gear ratios. You're not mixing it with mechanical advantage. So, yeah, that's all I want to say about that.